Welcome back. Problem 9.81. So statement is for the uniform being shown. Determine A, the reaction at A and reaction at B. So you can see this is the beam AB and that is acted upon by a uniformly distributed load from A to C. And this load is W. The total length of the beam is L. Clear? So as we know that you can see that if you remove this roller support at point A, so definitely there will be a reaction force at point A, and if you remove this big support at point B, so there will be a reaction force at point B. Clear? That will be in this direction. This will be RB, and there will be a movement as well at point B. So you can see there are three unknowns RA, RB, and there is a moment, and we have two equations and there are three unknowns, so we cannot find this reaction in this method. This problem is indeterminate. Clear? So how we will solve? We will solve then by using method of superposition. So what we will do is that we will take this distributed load till the end of this beam. Clear? And again in below portion we will also mention in order to counter effect, in order to cancel the effect of the above this portion which we have added. So now we will split them into three cases, and I will show you the first case is loading 1. So if I draw this beam like this, and there is a reaction force at point A, RA, and if this is the fixed support, and let the total length is L. Clear? This is point A and this is point B. And similarly we will take the loading 2. The loading 2 will be like this. If this is the uniform, if this is the beam, and this is point A, this fixed support is point B, and there is a distributed load at it. We will draw all the cases and then we will solve them. So if this is W, the total length of the beam is L. And third loading is that like loading 3 will be like this. So we will draw the same beam. This is point A, this is your point B, and at half of the portion there is a uniformly distributed load upward, and this will be your point C. So from C to B the distance is L by 2, and this remaining distance will be also L by 2. Now what we have done, we have taken this beam and load at point A, which is RA, separately. Then in second scenario we have taken the upper uniformly distributed load that is shown over in second loading, and in third loading we have taken only this distributed load. We will find the deflection equation for each of the cases. So let's move and we will solve this. So you can see this is the loading, this is case 1, loading 1. So if you go to appendix D of your book, so you can see that this is the beam and loading. I will choose the pen. This is the beam and loading. This is elastic curve, this is maximum deflection, this is slope at the end. So in our first case you can see the simply supported beam at one end is given by a load P. I will switch over. You can see here the load is upward. So the same case L, and this is a cantilever beam. So in this case you have deflection is given as this one. Since the deflection is upward, so this value will be positive, and P is replaced by RA because in that we have RA. So I will write that again. I will switch over. So in this case you have YA for loading 1 is equal to RA. P is replaced by RA. So RA L cube over 3EI. How? So you can see due to this loading, this beam will behave like this. So this will be its YA1. Clear? Similarly, for loading 2, I will go to the scenario where a cantilever beam with a uniformly distributed load. So you can see this is the case 2. This is case 2 with uniformly distributed load. So in this case, the deflection YA of 2 second loading condition will be minus WL cube over 8 EI. So I will write this for case 2, YA2 will be equal to minus WL4 over 8 EI. So it means that due to this loading, this beam will deflect like this, and this is the YA2. Clear? Now we will go toward our third scenario, and in third scenario you can see we will use the same distributed load condition, but that is for L by 2 because this load is acting at a L by 2. So we will use the same case this, but here the L will be replaced by L by 2, and this theta, this negative sign will be positive because for the loading shown upward, deflection will be upward. Clear? So it will be like this. So this will be positive number, and in instead of L you will put L by 2. So let's do it. So Y, now you can see due to this loading the deflection will be like this. Sorry, not a straight line. It will be like this. So this will be the deflection. This will be the deflection at point C. So we will find this deflection of YC for loading 3, and that will be equal to W into L is replaced by L by 2, 4 over 8 EI, and that will be equal to WL4 over 128 EI. Now we will also find theta C for this loading 3, and this theta C for loading 3 is this angle. This is the theta C, and same will be the theta A because this will be a straight line. Clear? So theta C is equal to, from this appendix, it will be, we will choose that from this appendix, this will be your theta C, but this will be positive, and L is replaced by L by 2. So theta C will be equal to W into L by 2 whole power 3 over 6 EI, and if you simplify it, it will be WL cube over 128 EI. Now you can see that this deflection at point A, we are interested in to find this. This is YA, and this YA is equal to YC. Clear? And this is for loading 3. So YC3 plus theta C3 into L by 2. I will explain it. You can see this YA will be equal to this YC, clear, and this remaining distance is theta C, and this distance is L by 2. So by using S is equal to R theta, you can find R is L by 2 and theta is this one. So you can put and you will get this displacement. So let's put the value. This total YA at point 3 will become equal to YC3, which is WL4 over 128 EI, plus this theta is WL cube over 128 EI multiplied by L by 2. Clear? And that will be, this is 128, this theta C is 48, not, this is not 128, this is 48, because 8 6 are 48. Okay, so again this will be also 48. So again, if you simplify it, it will WL4 over 128 EI plus WL4 over 96 EI. And again, if you take the LCM, it will be equal to 384. So 384 when divided by 128 will give you 3. So it will be 3L WL4 plus this will be 4 WL4. So from here you will get 7 WL4 over 384 EI. Here we have also EI. So this is YA at 3. Now you can see that we have 3 YA, YA1, YA2 and due to YA3. So due to the superposition, we will all add this. So we will write due to superposition method and constraint, we will add them. So YA1 plus YA2 plus not 3 2 plus YA3 is equal to YA. And again you can see that in the start this is a simply support, so due to this loading the beam will deflect like this. It will deflect like this. I will show you. It will deflect like this. Clear? So what does it mean? It means that deflection at point A is equal to 0 because there is a roller support at point. So it means that there YA1 plus YA2 plus YA3, this is 2, plus YA3 is equal to YA, and that is equal to 0. So you can put the value YA1 is RAL cube over 3EI plus YA2, which is this one, minus this one, minus WL4 over 8EI, this will be negative, plus YA3, which is 7 WL4 over 384 EI. Their sum must be equal to 0 because deflection at point A, total deflection at point A is equal to 0. So when you solve this, again it will be RAL cube over 3EI minus 41 WL4 over 384 EI. It should be equal to 0. So from here you will get reaction force at point A is 41 WL over 128. So it means this is positive, so RA is upward. Now we will find RB. So RB can be found by using equilibrium conditions. Sum of all forces about upward is taken as positive. So we know that there are three forces that is acting. One is RA, the second is W into L by 2, which will be acting downward, and third one is RB. Their sum must be equal to 0. So I will write it. RA is 41. RA is 41 WL over 128 minus W into L by 2. That is distributed load converted into point load plus RB is equal to 0. So from here you will get RB is equal to 22 by 128 WL. That is upward. Let me check how we have taken RB. So RB is taken as here downward. So you can see, you can put it negative. So it means that RB will be a negative. So we have taken negative, and this negative means that your assumed direction is wrong. So it should be upward. So either you have to correct it. Let me correct it. So RB should be upward, and this RB is 22 over 128 WL. So it should be upward. So we will, here this shows downward, but we have assumed. So RB should be upward. Why? Because we have taken already negative sign over here, but the answer shows the negative, so it means that our direction should be upward. So now if I represent the beam, free body diagram of the beam like that, so you can see there is point RA, and this RA is equal to 41 over 128 WL. Clear? And RB is also upward, and that RB is equal to 22 over 128 WL, and there is a moment about point B, and if we convert distributed load into point load, so it will be W into L over 2, because that is acting at a L by 2 here. This is acting at a L by 2, and it will be equal to WL over 2. And what will be the position? It will be L by 2, and from total it will be 3L by 4. So I will write it. It will be, this distance will be 3L over 4, and this will be L by 2. Now we will apply equilibrium condition, that sum of all moments about point B is equal to 0. This is point B, this is your point A, and taking the counterclockwise moment as positive. So moment about point B is RA into total distance is L. So RA is, and it is producing clockwise movement, so it will be negative. So minus 41 WL over 128 into perpendicular distance is L, minus plus this moment due to this WL by 2, and perpendicular distance is 3L over 4, and it is producing counterclockwise movement. So WL over 2 into 3L over 4 plus this moment, which is counterclockwise, minus MB is equal to 0. So when you solve this, definitely MB will be equal to minus 41 WL square over 128 plus 3WL square over 8. So by solving this, you will get moment about point B is equal to 7 over 128 WL square. So this is the moment about point B. So this was all about problem 9.81, in which we have calculated the reaction force at point A, at point B, and there is a reaction moment at point B. I hope you have enjoyed this video. Also, those who are new to my channel, then subscribe it and keep watching. Thank you.